Okay, welcome back, everybody. Today, I know you're looking forward to seeing your test, but you're not going to because a lot of people have still not taken it, like a lot. Like I've got like 12 kids that did not take the test yesterday based on, I get it, a lot of people were gone and a lot of people were absent yesterday because they were still on vacations and whatever. So anyway, I can't let the answers get out there before a lot of kids have taken it. That would not be fair to you, really, because you don't want kids to be able to get easy grades on this test that was really hard for you because they cheated and got answers from a friend. So, not giving you the results back yet, except you can see how you did by looking in Skyward. It was, I'd say the average was probably a C. It was hard. I warned you that was going to be hard. And all I can do right now is just say, yeah, that was a hard test that you're done with. And this next one is not a picnic either, but I think that was one of the hardest. There's one more coming, not this next one, that is going to be really, really hard like that. So I warned you, Trig's not easy. All right, so stay with me today. It's completely new. I mean, it goes back to Trig that we already know, but it's completely different stuff. So you're not going to be like beat over the head with the same exact thing you didn't understand for the last test. You're going to be able to go on to something new. So ask yourself, give yourself license to, okay, that was rough stuff, but I'm done with it. I got to get back in the groove, and most of you were getting A's and B's before. You can get A's and B's again here. Just kind of keep an open mind that not all Trig from here on is going to be impossible. All right, let's talk about just solving equations. If you had 2x plus 7 equals 15, you remember when math was that simple? So how would you start? You'd subtract 7, and then what would you do? Divide by 2. It'd be pretty easy, right? Okay. So what if this was sine of x plus 7 is equal to 15? Okay, well, don't just go blank just because there's a sign in there. It's still the same basic idea. You'd subtract 7 from both sides. Okay. And then you'd have subtracting 7, 15 minus 7 is 8. Will sine ever equal 8? Think about it. What's the highest sine ever gets? 1. So this would be one that would be impossible, wouldn't it? Because sine can't be 8. So you do have to be aware that sometimes they're impossible. Usually, do you remember we were using theta for our variable too? But let's say it had been this. How would you say that it's impossible? You could write the word impossible, I suppose. What's the more mathematical way to say this? What they're asking for is an angle. What's the angle? There is no angle. You could say no solution. That'd be an okay way to say it. Or undefined. All right. So, what could you answer? What if it had come out to 1/2? Could you get an angle for that? Yes. Now let's go back to, let's say that was the question. Sine of theta is 1/2. But still, it's an equation. We're trying to get the theta alone. Do you remember how to do the thing that undoes sine, gets the theta alone? It's inverse sine. And if I do inverse sine on both sides, this will cancel off. And now I've got theta is the inverse sine of 1/2. Usually I'd have you do a rewrite then, right? I know it's interesting, the guys in the room, but look at this. Okay. I'd have you do a rewrite of this. And I would say the same thing we said before. Sine of theta is 1/2. Okay, so really it's just how many degrees is that? And hopefully you've got this one memorized. Sine of what is 1/2? 30. But if you hadn't had it memorized, how would you do it? You'd have to go back to your 30, 60, 90 triangle. You know that 1 and 2 are the sides of it. Sine is opposite over hypotenuse. Opposite's 1. Hypotenuse is 2. This must be square root of 3. And hopefully it'll start ringing a bell and you'll be like, oh yeah, sine of 30 would work because the 30 is what's across from the 1 there. But there's more than one answer. Once again, do you remember how there's 2 angles that'll work here? We got to think bigger picture. Got to think like in the big circle, the circle of life. You could get it to work right here. Sine of 30 is 1/2. That's one of the places that it works. But all students take calc. There's more than one place where sine is positive. Do you remember that? Yep. So this place worked. 30 was right. 30 is one of the answers. But there was also, sine was positive. All of them are positive here, but sine's also positive there, positive a half. So I can go over here, draw myself another triangle, and this one's going to be very close, but a little bit different. It's still 1 and 2, but what is it for the bottom? Negative square root of 3. Okay. And then the answer is, well, this is 30, but this 30 is right here. What's this spot really then? If it's not 30, it's all the rest of the way here, which is 100 and 150. If we were doing this all in radians, we wouldn't have said the answers were 30 and 150. We would have said they were pi over 6 and 5 pi over 6. This one's the same as 5 30s, right? So it's 5 pi over 6. Does that ring a bell? Remember doing those? All right, something very similar to that today. All right. Another thing that we have to be good at is to be able to handle ones that have quadratics in them, which can be factored. Some of you caught this before the test. Some of you are only going to catch this now. I was telling you how you can factor things like this. Do you remember? This is just like x squared minus 1. Let's say it's equal to 0. It's just like x squared minus 1. You can factor that. And you'd factor it to x plus 1 and x minus 1, right? Some of you caught that, and that was used on the test the other day. So tell me what this one would factor to. What would that factor to? Factor it right now. Now I'm going to have you paired with the kid across from you. And a person across from you, I want you to compare your answers with them. The first rows 1 and 2 there, rows 3 and 4 here. Actually, you guys are row 1 and 2. But anyway, these two rows, compare with the person across from you. Tell them what you think it factors to. If they don't know, explain it to them. I'm pausing. Okay, that was actually ridiculously easy. It was sine plus 1 and sine minus 1. All right, so now, do you get how about if I say it this way? Let's say the problem had been an x and a y, or sorry, an x plus 1 and x minus 1. Do you get that then you'd set this one equal to 0 and get one answer for that? And then you'd set this one equal to 0 and get one answer for that? Remember that? There'd be an answer here and it's negative 1, and there'd be an answer here and it's positive 1. So there was two different answers, right? Well, same idea on this problem. We have an answer or maybe even two answers for that. And then we'll have two answers for this. This is how you can sometimes have four answers for a trig question. All right, so let's do this one. Do you get, we always set this part equal to 0 and that part equal to 0. It's two separate things. So I'm just going to do one at a time. I'm going to start with, I'll start with the one on the left here. Sine theta plus 1 equals 0. Now, don't go brain dead from algebra and forget how to solve an equation. Is this set up? Well, how about this? What should I do next? Subtract 1. Just have to subtract 1 from both sides. So sine of theta equals negative 1. Now, that's going to lead me right back into what you've already been tested on, is can you take this and turn it into two angles? Think about it. Does sine equal negative 1? Does sine ever touch negative 1? Yeah, it touches it a whole bunch of times. Think about the graph of sine. Sine goes like this, and it keeps touching 1 over and over again. It touches 1 here, and it touches 1 here, and keeps touching it over and over and over again. Okay? But between 0 and 2 pi, how many times does sine touch negative 1? It touches negative 1 just once, right there. And do you know where it is? I've got it memorized. Do you have this memorized? Remember those 4 spots on a... This is up to 2 pi. When is sine negative 1? At this spot right here, which is what? 3 pi over 2. And what's the spot where sine is positive 1? Because, see, that's the other one. This one right here. Sine of some angle. Oops, I didn't have a theta in there. Minus 1 equals 0, so add 1 to both sides. Plus 1, plus 1. Sine of theta equals 1. And then I have to get however many answers I can for that. But again, between 0 and 2 pi, that cuts us off from here to here. Sine is only 1 once, right here. And sine is only negative 1 once, right there. So this one's 3 pi over 2. And this one is at, what's that spot right there? Pi over 2. So this one will be pi over 2. Now, I'm doing it kind of in an unusual way by showing you the graph for it, but I think it's good for you to remind yourself what these graphs look like. Could I have done this another way with quadrantals? Yeah. I'm going to show you that other way. So let's say it was here, and you had no clue what the graph looked like. You can still do it. Do you remember that sine of an angle is y? Sine y? Does that ring a bell? Cosine of the angle is x, and tangent of the angle is y over x. So, if sine's supposed to be y, you'd ask yourself, where is y negative 1? When you look at your picture of things and you say, where is y negative 1? It's down here. And what angle is down there? 3 pi over 2. And over here, where is y positive 1? Y is positive 1 right there. And do you know, well, first of all, I could make the list of points. This is 0, 1, but that's where y is 1 right there. Okay, so then if this is my spot, what's this? Pi over 2? 3 pi over 2? What is that thing? Come on, I need some audience participation here. I'm not asking you hard questions right now. I need you with me. So what's that one? Pi over 2. Thank you. All right, so you could have gotten these two different ways. 3 pi over 2 and pi over 2, you could have got them from the quadrantals, or you could have got them from the picture, which I showed you before. But what did it start as? It started looking like this. It's an equation. So this whole topic is called solving trig equations. And half the time, it's about factoring things. And once you've got them factored, you just take each part and solve it separately. All right. Let's do another one, except let's see if you can handle this one. Sine of some angle plus root 3 over 2 is equal to 0. Solve it. Notice this one is not squared. There is no factoring involved. Okay, in a moment, I'm going to have you show this to the person that you are working with today and see if they got the same thing as you, and if they're struggling, help them. I'll help you start. You should have subtracted root 3 over 2 off both sides. And you'd end up with sine of some angle is negative root 3 over 2. Don't forget that there's two places where sine is negative. All students take calc. Sine is negative in two spots. Therefore, you need two answers. And neither one of those, here, I'll help you. Sine is positive here and here. That means that your triangles, when you draw them here and the other place, those triangles, they are not angles like 30, 60, 90, or 45. They are reference angles that you'd be finding. So you need to find the big angle. It goes all the way around to here and all the way around in there. So these are big angles, like 5 pi over 6 or 11 pi over 12 or bigger than that even. I'll pause while you finish that. Okay, here's what you should have been thinking. If this triangle right here has got to have, from the reference angle, opposite be this, and hypotenuse, some of you are still talking, please stop. Hypotenuse needs to be that. Then, if the opposite's negative root 3, and the hypotenuse is 2, and this is a 1, then which side's across from the negative root 3? That's a 60, but it can't be a 60 because it's got to be all the way around to here. So the reference angle is 60. So then, if I do it in degrees, I'd have 180 plus 60, which would be 240 degrees. If I want to do it in radians, then I got to change 60 degrees in radians is pi over 3, and this would be 4 pi over 3 for this spot right here. 4 pi. Did I do that right? How many of you got the same thing as I did? Okay, good. All right. Then there must be another one. You don't have to reinvent the wheel. You can say, oh, I know it's 60 right here, but it's not going to be 60. It's going to be pi over 3. And then you got to say how many pi over 3s to get all the way around to here. Well, 6 pi over 3 would be all the way to here, but we're backed off once from that, so it would be not 6 pi over 3, but what? 5 pi over 3. 5 pi over 3 and 4 pi over 3. Yes, sir?
Could you also had negative pi over 3 and negative pi over 3?
You only use negative numbers when you're doing inverses, and this was not an inverse question. The other thing is they're going to say give your answers between 0 and 2 pi. And the answers you just gave me, oh wait, except it can be 0 and it can't be 2 pi. So the answers you just gave me are negative, they're outside that zone. Okay? All right. So, one more thing. If you had this, could you just solve that one for me quick? In a moment, of course, it'll be a trig question like that, but we got to make sure you get how to do this first. You're very distracted today. Put that away. Awesome. All right, you should be thinking there's x's on both sides. Now, some people right now will subtract 3 or subtract 9, and that's actually okay, but it's not the best thing. The best thing is to deal with the fact you have x's on both sides first. That way you'll make the least number of mistakes. So if there's x's on both sides, you should subtract the smaller one. You should have subtracted 2x from both sides. Now, some of you might say, but I always like to do you can do the 3 or the 9 if you want. It's just that you might end up putting it on the wrong side. Because now, see, once I do this, I can tell that the variable is going to be on the right side. And for those of you that subtracted 9, you guessed right and got lucky. If those of you that subtracted 3, you wasted time. You did an extra step you didn't have to. 3x minus 2x is 1x plus 9. Now I'm going to subtract 9 from both sides. And I have 9 6 equals x. That way it's only 2 steps. Okay, so you get rid of the smaller x. This step right here. How many of you guys had, oh, negative 6. How many of you guys had negative 6 as your answer? Okay, good. Then, do you get how this is going to be basically the same thing? Your variable is kind of like the sign. And yeah, I should throw another x there. So again, you could start by adding or subtracting the 1 and the negative 2 and stuff. You could, but don't. Much smarter to deal with these first. And which of them do you get rid of? It's kind of the whichever one's smaller is easier to handle. Do you agree in general that's true, unless you get the microscopic size? Okay, but in general, it's easy to handle a smaller thing. So I'm going to handle this one. That's smaller. And I have 3 minus 2 is 1 sine x, or just sine x, plus 1 equals negative 2. And then I'm going to divide by subtract 1. And I'll have sine x is equal to negative 3. When is sine ever equal to negative 3? Never, because what's the lowest it ever gets? And therefore, this answer is no solution, undefined, etc. Okay. No solution is probably the best one because there is not a solution. All right. So be watching for the ones that are quadratics. Because you'll have to factor them. Remember, this part here would factor. And once they're factored, you take each part and set it equal to 0 separately. Sine x plus 1, sine x minus 1. And this one equals 0 in probably 2 places. And this one will equal 0, although actually these only equal 0 in 1 place each. But we actually end up, by the time we're done with this whole thing, with problems that are so complicated, you end up with 6 radian answers to answer the question. And then, to make it even worse, one of them will not actually work. So that's where we're going eventually. But this is day 1 when it's still all doable and relatively easy. Okay, why don't you check the Wi-Fi and see if it's working yet? Because if it is, we can just start our worksheet together. If it's not, I'll have to have you copy the first few problems down. Hopefully you can get into the Google Drive and find, we renamed them to just solving trig equations day 1, 2, 3, and 4, and 5, I think. So today is solving trig equations day 1. Do you guys see that in your folder? Some people are seeing it. Good. Sounds like Wi-Fi is working then. I'll drag this puppy over here. This first one, super easy if they hadn't used root 2 over 2. Do you remember that that's not one of our triangles? You know how the triangles we have are 1, 1, and square root of 2, and that's for the 45, and 30, 60, 90. That's 1, 2, square root of 3. Does anybody remember what we should change root 2 over 2 into that would be the exact same thing and it would be one of our triangles? Only one person remembers? I'm glad you remember. 3 people maybe have it. 4? Okay. Here's what you do. You find some other ratio on this screen, like this to this. Is that equal to this to this? So, and I also gave you the hint that if it had a square root of 2 in it, then the new ratio also has a square root of 2 in it. So now, who's certain they've got it? Yes, sir. 1 over root 2 is correct. So now, if we change this, and how do I know for sure? Because if you go, 2. If you go that times that, it will be a square root of 4, which is 2. And that times that, they should equal each other. Do you get that they do equal each other? Okay, so we can change this problem to say 1 over root 2. Now we'll know which triangle we're in. We got to be in that one. It's the only one that has 1s and root 2s in it. So then our answer's probably 45. But remember, there's more than one answer. This little clue here, that the answers are between 0 and 2 pi, means there's usually a couple answers. So you draw your little picture with ASTC. All students take calc. And you try to figure out where is sign positive. So it can't be here and it can't be here. And then you draw your triangle here, which is the 1, 1, square root of 2 triangle. So yeah, it is 45. But what's the other one? It's over here. Negative 1, 1, and square root of 2. And that one is also 45 here, but we don't say 45, we say all the way around to the 45. So 45, if you go radians, since they want the answer between 0 and 2 pi, that implies they want radians. 45 in radians is pi over 4, and 45, this kind of 45, that 45 is a reference angle, is how many pi over 4s? 1 pi over 4, 2 pi over 4, 3 pi over 4s. So 3 pi over 4 and pi over 4. All right. The next one has factoring. The next one after that has factoring. The one after that, it has factoring. Okay, so you obviously have to be ready for factoring. Let's factor on this first one. Do you get how both of them have a cosine in it? So that's what you do. You factor out the cosine. Cosine of x comes out. And when you're factoring, you're really dividing then by that thing you're putting in front. I'm really dividing by cosine. And that means I would have 2 cosine x. And cosine divided by cosine would be plus 1. If you can't do it by dividing both of them by cosine, if that doesn't work in your brain, then you got to just make sure that what you multiply out, that times that, and that times that, better equal your original one, which mine does. Okay? Now that it's factored, this part equals 0 is part of my question. Where is cosine of x equal to 0? I can do it with the picture, or I can do it with the quadrantals. I'm going to do this one with quadrantals, as opposed to the cosine wave, which would have been like this. I could have done it that way too, but all right. But I'm going to do the quadrantal way. And where is cosine 0? Well, that's cosine is the x. Sine's y, cosine's x. So it's really about if x is 0. X is 0 at this spot and this spot. Those are 2 spots where x is 0. So those are 2 quadrantal spots. What's this one called? Come on, it's this one. Pi over 2. Pi over 2 is one of your answers. And what's this one? 3 pi over 2 is the other answer. Could I have done that from the picture of the graph of cosine? Sure. Graph of cosine looks like this. When does it hit 0? Oopie. Actually, yeah, I shouldn't have marked that one. That's pi over 2. This is pi. This is 3 pi over 2. And the ending of it is at 2 pi. So it hits here and here at pi over 2 and 3 pi over 2. See how you could do it with a picture? I don't know. I don't know if that's helping you or not, but that's a way that helps me to know if I'm doing it right. Quadrantals, if you understand that sines y, cosines x, and tangents y over x, is a good way too. Okay, we're not even done with that question. That's just answering the left side. Now, how about this part? We have a new equation, 2 cosine x plus 1 equals 0, and you set it equal to 0 and you solve it. Subtract 1 from both sides, makes this negative 1, divide by 2, quiet that down please, and cosine x is equal to negative 1/2. Once again, I can try to do this with the graph of it, but I personally am going to use a draw my triangles approach. All students take calc. Cosine, ka, adjacent over hypotenuse. Oh wait, I got to know where to draw it first. Cosine's negative, so it can't be here and it can't be here. So then my 2 triangles are here, and then the other one, I'll do the blue one first. Cosine, adjacent over hypotenuse. The adjacent's negative 1, the hypotenuse is 2, and this must be square root of 3. And the angle that's across from square root of 3 is the 60. So if that's a 60, also known as a pi over 3, this must be 2 pi over 3s. So I already had these two answers. All right. And now I'm going to have another answer for this one, which was 2 pi over 3. And then one more answer for when you get this triangle right here. It's the same 60, it's just you got to figure out what that is to go all the way around to here. Okay, there's a lot of help getting started. And I feel like this worksheet is a little longish for what you could be realistically expected to do on a mass day where we don't have as much time. So I will cut out a couple. Let me try to do strategic ones that I know won't be that big of a deal. Let's skip M and K. K and M. All right, that's all I have for you for today. You can back.